Just put it in the folder right now. For completing the square? Yeah, put it in your folder. Okay. We did example 5 and example 6, method 1 last time. We're going to start with method 2. Okay, method 2. If f of x, Miklo, do you have a binder to keep yourself organized? Then where was it? I gave it to you last time. All right, are we ready? Chris, you ready? Isabella, you ready? All right. So, method 2. F of x equals 2x squared. What type of a function is that? Isaiah Cooper? What type of a function is f of x equals 2x squared? Give me a hint. Starts with a Q. Why do we know it's quadratic? Because what? The squared. The highest degree is a 2, x squared. And we have a second function, g of x equals x plus 10. If we raise a hand, you can tell me what type of function g of x is. Kevin? Linear. How do we know it's linear? Well, it does. It's just not written because we don't have to write it. Because what's the exponent on the x? It's a 1. X to the first power is linear. So this one's going to be something like a U. This one's going to be something like a line, and they're both positives. This time, they're equal to. Is that going to be solid or dashed? When it's equal to, is it solid or dashed? Solid. We did a graph last time, right? That was a dashed parabola, correct? Okay, so both of these are going to be solid. Colby. I don't think you're earning any popcorn right now. The inequality, let's see, if those are our functions, find the inequality that we want to solve so that f of x is less than g of x. We want to know when f, the parabola, is less than g, the linear line. We need to graph the functions and find where they intersect. Okay? So it's easiest to see when the f is less than by looking at the graph. So we're going to do a table of values, x and f of x. F of x is interchangeable with y. We need to get some points. Please take the earbud out. All the way out. I'll let go of it. Thank you. F of x is interchangeable with y. So this is like an xy table. We want parabolas, when we're graphing, to be centered at the vertex. Does anyone know the vertex for 2x squared? It's a point. The point for the vertex. 0, 0. Do you know why? K is 0. After the squared, there is nothing. So this is our vertical shift. And inside is the horizontal shift. And we say opposite, same. Is there anything being added or subtracted to the x inside parentheses being squared? There is not. 2 is being multiplied. So there's nothing like in parentheses with the x being added or subtracted. So this is 0. And this is 0. So the vertex is 0, comma, 0. Because after the square, there's nothing either. So I'm going to put that in the middle. And I'm going to put a box around it because I should see symmetry coming out of that. I should get some repeats because of symmetry. Let's do a couple x's smaller and a couple x's bigger. Go in order. A couple x's smaller and a couple x's bigger. Because of symmetry, we know we're going to have some repeats, so I'm going to choose to plug in the positive x's. Okay? 2x squared. If I plug in positive 1 squared, 2 times positive 1 squared, fingers in the air, What's the answer? 2 times 1 squared. Fingers in the air. What do we get? I see 2 different answers coming out. You have to do exponents first. 1 squared times 2 is 2. Good. Okay, fingers in the air. What's the answer to this one when we plug in 2? 2 squared times 2, because you have to do exponents first. What do we get? I see 2 answers. Be careful. 2 squared is what? 4 times 2, so you should have 8 up. Now, because of symmetry, what's the y that goes right here? Not negative 2. Positive 2. They'll be the same, because they're both 1 step away from the vertex. And these that are 2 steps away from the vertex, that blank will be an 8. Okay? Let's go plot those points on the graph. It should be a parabola, so we should notice a U shape happening. Now, the graph is, yours is a little better copy than mine. Mine's kind of hard to see, but you can see there's a negative 4 way out there. So we have, you probably want to go through and mark it first. Negative 4, negative 3, negative 2, negative 1, 1, 2, 3, 4. And you can see there's a 1 right there, so it's saying each vertical, or I guess horizontal line up the y-axis is counting by 1. 6, 7, 8, 9, 10, 11, 12. Probably want to make sure those are clean before. Okay, now you need arrows. It needs to go all the way up. Okay, plot the points. Negative 2, comma 8. Negative 1, comma 2. Are we okay plotting points? Does anyone need help plotting points? 0, 0. 1, comma 2. Now we start seeing symmetry. Those are the same height. And 2, comma 8. Those should be the same height. Make sure your points are large enough so that when you draw your U, the parabola, through it, you can still see the points. And go all the way up with arrows. Because we're trying to see where these intersect. So you have to see the whole graph. Please copy what we have there and draw the graph. Alrighty, that is f of x. Since we were dealing with 2 functions, we should label it. And this was supposed to be solid because it's equal. Sometimes we'll have to do dashed parabolas, so make sure you're paying attention. G of x, you've already said is linear, so let's get some points. It should look like a line. Ugh. I don't know why it's not. There we go. Okay, do you remember standard form of a linear function from 9th grade? Yeah? That's quadratic. Yeah, I have a little song and dance for this one too. What is y equal mx plus b? Students. Oh, junior high was so fun. Students, are you listening to me? Students, there's an m and a b. Okay, what's m? M is slope. Do we have a phrase for slope? Rise over run. What's b? The y-intercept. So if we look at our function, we have x plus 10. We need to start with the y-intercept. Toby, what's the y-intercept? In the B position. What's in the B position in the function above? 10. Okay, so put a nice solid point on 10 on the y-axis because it's a y-intercept. It should be on the y-axis. From there, we use the slope to get more points. If 10 is the y-intercept, what's the slope? there's 1x. So that is 1 over 1 for a rise and run. So from 10, we go up 1, right 1, up 1, right 1, up 1, right 1. What? The x's are on a different interval than the y's. The y's was counting by ones, and the x's were actually counting by about halves each line. Okay, then we can do reverse of that to get more points. Go down 1, left 1, down 1. Ooh, interesting. What just happened? They intercepted at the exact same point. Down 1, left 1, down 1, left 1. And it should be a line, linear, like we predicted. So, because of the equal sign, it is a solid line, g of x. Okay? So, this says we want to find when f, my blue one, is less than g, the green one. When is the blue one less than the green one? It says when is f, the blue one, less than g, the green one? Visually, what does less than mean? Visually, what does it mean? You said it, Jeff, or AJ, someone back there said it. It means what? Underneath. So at what point does f start going underneath?
Right there.
After it steps away from this point. Here they're the same. Once you step away from it, then you're underneath. So that happens about x equals -2. Actually, I should use a parenthesis because it's after we leave the point. Then it stays less than or underneath until I get to where? About there. What's that x value? 4 is way over here. It's somewhere between 2 and 3. We don't know exactly. I'm going to show you on your calculator how you can find that. So, open up those calculators, please. Where's my calculator? Open up calculators. Go to y equals. We need to see these graphs. Okay, how do we graph? Okay, that's not the question I'm asking. How do we graph? Y equals. What's the f function? 2x squared. And then we have a second function. So we arrow down. What is the g function? X plus 10. Everyone should be doing this. Okay, if your window's good, you should be able to see it. Let's hit graph. Oh shoot, it nearly got cut off. So on the y-axis, we need a little more y. Yeah, yours is really off. Go to window, or zoom actually. Sorry, hit zoom, Colby, and do number z standard. Is that number 6? Yeah, yours is good. Leave it there. Okay, if yours is like mine and it gets cut off, I need to see more on the y's. Do I need to see more on the y maximums or the y minimums? Maximum. So if yours is like mine, you need to go to window, go down to y max, and I need to change it. Instead of being 10, I'm going to change it to like 20. Y max I'm going to change to 20. And then I hit graph, and now I should be able to see both intersections. Good. We already know what this one is. We're going to find this one. We can do that by calculating it. Do you see above the trace button in blue? What does it say? Calc. That's what we want. So would everyone go second trace? Equal? Second trace, please. Which one will help us find where they cross? Number 5, the intersect. So we did second trace, now we're going to select number 5. At the bottom of your screen it says first curve, and we have this blinking little bug. I'm going to arrow it over until I get as close as possible to that intersection. Once I'm as close as possible, I'm going to hit enter. My calculator then says second curve. So sometimes you have to adjust a little bit because the second curve means that now I'm on the line. So you want to get as close as possible to that intersection, hit enter, and then it says guess, hit enter for a third time. What is the intersection? Okay, keep those numbers in mind so I can put them on mine. Okay, so we found out that this point was, what was it again? 2.5 comma 12.5. So about in here, they intersect. So our answer f of x is less than g of x on the interval where, Colby, turn, put your feet down, turn, pick up your pencil, please. On the interval from -2 to 2.5. Now there's differences between open parentheses and closed brackets. When we are exactly on the intercept, was g less than? No, because they're equal. So it's not until we step off the point that it becomes less than. So I have to use parentheses. This is an interval of time when g is less than, from -2 to positive 2.5. These are x values. That's the y value. The x value of that is 2.5. Okay, so they're x values. Then we had another question. When are they equal? F of x is equal to g of x at what points in time? Okay, there's two ways we can write this. At x equals -2 and x equals, what's the x? 2.5. Or you could say the points at -2 comma, what was it, 8 and 2.5 comma 12.5. You can say it either way, but you can't just say -2. It either needs to be in the point, or you need to say x equals -2. Whoa, sorry. Okay. After you have those written, please flip to the next page. And at this point, take your hands off the calculators. Back away from the calculator, please. Okay, we're going to do example 7. We have two functions. This time they're different, and we have a through g above that we're going to answer. If you have large handwriting, we're going to want to try to write smaller because there's only so much space to answer a through g. All right? So starting with a, we want to solve for when f of x equals 0. Colby, what is f of x? Negative x squared plus 3. So we're going to put it equal to 0 because it asked us to find when f of x equals 0. Yeah? After we finish this problem. This is also finding, if you're assigning equal to 0, it's finding where it's on the x-axis. So it's finding x-intercepts. So would you solve that, please, for x? And probably write small because we have a lot that's going to be in this section of the page. Solve it for x. Yeah, solve it for x. Inverse operations is what we use to solve. Okay, how do you get x by itself? What are you going to do first? What's next to the x that we need to move? That, right? So how do you move it? Yep, both sides. Okay. So now keep solving for x. What was the first step, AJ? Subtract 3, both sides. We have to get rid of the 3. We want to get x by itself. So we have negative 3 equals negative x squared. Can I take a square root now? No. You're going to be taking square root of negative. We don't want to do that. What do we need to do to get rid of the negative sign? Divide by negative 1. You can also times by negative 1. They would both do the same thing. So divide by negative 1. Dividing by negative 1 changes the sign. So it's positive 3 equals positive x squared. Okay? Chris, now what? Now we square root. So we have x equals, if we apply the square root ourselves, what has to go in front of the square root sign? Plus or minus. So this means there are 2 intersects on the x-axis. There's a positive root 3, whatever that decimal is, 1.2, whatever it is. And there's a negative root 3. There are 2 places it crosses the x-axis. That's part A. Now we do the same thing but with g. So part B says set g equal to 0. Okay? Isaiah Cooper, what's g? So we're trying to set it equal to 0. We want to set it equal to 0. What is g for number 7? Do you see g of x equals? There you go. So we say 0 equals negative 3x plus 3. Solve that one for x, please. We want to know when g is equal to 0, meaning when g has x-intercepts. Where are the x-intercepts going to be? When you're solving, you should be using inverse operations. So when you subtracted 0 minus 3, that number should be negative 3. And then one more step and you're done. This one's not squared, so you shouldn't be taking square roots. It's x to the first power. Okay, Omar, what did you do first? Good. Minus 3, both sides. 0 minus 3 is what? So what? 0 minus 3 is negative 3, which equals negative 3x. Okay, Stetson, what would you do now to solve it? Good. Divide by negative... skinny marker. I want a skinny marker. Okay. Divide by negative 3. Anything divided by itself is 1. So we have 1x equals anything divided by itself is 1. So no need to take square roots. There's only one intercept. Okay, next we want to see when they're equal to each other. Part C, f of x is equal to g of x. Okay, bye. F of x is equal to g of x. That means we take f of x and set it equal to g of x. Elena, what is f of x? Because we need to set it equal to g of x. What is f of x? Yep, negative x squared plus 3. We're going to set it equal to g. Arya, what is g?
Negative 3x.
Good. Negative 3x plus 3. This part's f. When we set it equal to the g, f equals g. Now, all we have to do is solve. What's our highest degree in this? X squared. So that means it's a quadratic. When we solve quadratics, we need to get everything to one side. And we want 0 on the other side. Okay, and we also want positive x squared. So is this a positive x squared? No, it's a negative x squared, which means we don't want to put everything on the left. We want to move everything to the right so that it's positive. Okay. Christian, C, how do I move the negative x squared over that way? Except for it's negative. What's the inverse of a negative? Add it. Yep. Positive. So plus x squared. Plus x squared. How do I move the plus 3 to the other side? Subtract it on both sides. And I'm going to make sure I line up like terms. Subtract 3. This board's having a hard time today. Subtract 3, subtract 3. So I get 0 equals. Make sure you write it in order. Which one do I need to write first? The x squared term. Standard form. Then I write my linear term. Noah, what's the linear term? Good. Negative 3x. And then my constants. What is 3 minus 3? 0. Yay. Okay, let's solve this for x. So plus 0. How do we solve quadratics? With quadratics, we can use the quadratic formula. Sure, we can do that. We also have, the easier method is factoring. If factoring works, that's easier. Factoring doesn't always work, but if it does, that's easier. Factoring works when our x-intercepts are integers, real integers. If it's a decimal, you need to be using quadratic formula. So can you think of two numbers, sorry I'm running out of room here, two numbers that multiply to 0 and adds to negative 3? Negative 3 times 0? Does that add to negative 3? X plus 0, x minus 3. But negative 3 times 3 would be negative 9, right? So one of them has to be the 0. Then we use the 0 property. What's the 0 property? What's the 0 property? Guys, we learned this like 2 weeks ago. What's the 0 property? Isaiah knows what it looks like. We do a squiggle, and then what? So we take each individual factor and set them equal to 0 and solve. X plus 0 equals 0. What number plus 0 equals 0? 0. So x equals 0. That's one time the two will cross. F of x equals g of x. We're looking for where they intersect. They'll intersect when x is 0. What's this one? What number minus 3 equals 0? Positive 3. Okay, those are the 2 points where the graphs will intersect each other. Okay, after you box that up, I want you to stand up, please. Stand up, please.